You go, you're wrong. So with that, I want to introduce Jess, who worked with me at Caspida, was it? He worked with me at Caspida. He worked with me as Splunk for a while. He's an awesome InfoSec professional, and he's now at a very well-known and up-and-coming startup called MD Logic. Am I pronouncing it right? Okay. So he's here to talk to you about Defend and Detect across your threat landscape. So give it up for Jess, please. Thank you.
Hey everyone, this is Jess, Joshua, but I go by Jess to make it easy for everybody to pronounce. Just quick, before I get started, I really want to understand, how many of you have been in the SOC? Either in the defender role or kind of a triage role? Well, I see a few hands raised up. How many of you, are tired of the lists that are coming your way, with the tools that you've been using, not being able to catch up with, how things are going on? That's true. The story kind of resonates with everybody, pretty much every SOC that we talk to. It's a similar strategy. So what we're going to talk about today is kind of going into the journey of how the SOC lives and what can we do to improve. What we have been doing that's helping some of the SOC teams that we are working with. So to get started, I'll kind of quickly go about introduce myself, my quick background of how I came along here, and then we'll go into the details of kind of taking an example of how the alerts are coming in, how they're being, reviewed, detected and whatnot. And then kind of taking an example of going into the automation side of the house. Let me get started. My name, like I said, just Brad kind of, give a quick introduction. I've had privilege of working with some of the really big startups. I started with Securonics. I was one of the founding member of the team, kind of being in that space of insider threat, build a startup from ground up all the way to I don't know if you're all familiar with Securonics, one of the leading SIEM solutions right now in the space. Then I joined Splunk or Caspida that got acquired into Splunk. Which again, we brought up Caspida from the startup days into one of its leading, vendors within the Gartner Magic Quadrant. And then I kind of transitioned into MD Logic recently, where again, it's a startup, we are a founding team. We are building pretty much like what we have seen in the past, in the last decade or so. I've worked with almost 400 plus SOC, customers trying to build their SOC and then kind of seeing the pain. And then we brought in the security professionals from different arenas, specifically the actual practitioners, the SOC practitioners, SOC managers and whatnot. And then we brought all of them and then kind of, started building this product. We kind of understand the core problem of how the SOC is functioning. And then trying to eliminate some of those, day-to-day workflow challenges with the product. Quick background about myself in terms of my technical expertise. I'm not just in the security, but I have a product experience building products, more of a product manager role. And then also being on the sales side and also as well as a code developer myself. So kind of being in different arenas to kind of get that experience. So let's get started, right? Typically you're all familiar with this pyramid of pain, where you start with this trivial hash detections all the way moving up to the TTPs. I don't know how many of you have been moving up the chain in that kind of pyramid level, but pretty much, if you look at any of the SOC, they do all of this. They kind of do the hash level detections with some of the tools that they have, hash or IPs or domain names, based on the threat intel that you already are receiving from various tools. And then you start building more complex level of detections by maintaining an asset management tool or whatnot to look at your network artifacts. And then you slowly going into the application space, and then finally looking at the threat landscape in terms of who are the threat actors, how are they doing, and then kind of do it, right? It's more of it's an IOC driven, especially if you're starting at the bottom of the pyramid, it's more IOC driven and it's very noisy, and the context is really, really limited. And then that's where a lot of people are suffering. And then people started as they go really to the upper part of the pyramid, it gets complex, right? And that's where the scarcity of the people comes into the picture. Because when you talk about SOC, one of the big problems is people retention are also getting the right set of skill set, like, to, ramp up the game, right? That's where, like, most of the SOCs are, suffering because, the TTP is, I mean, the low level detection is pretty easy. You have tools for it, but then as you go up the pyramid, you need more skill set. Like that's where a lot of human intelligence comes up. A lot of SOCs, like at least from what we have gathered in the past, they're all struggling with it because they really don't have the skill set, nor they have time, like, because of all the alert volume that is being generated with all these low level indicators, like, the hashes or IPs and whatnot. How do you solve this core problem, right? You may all be thinking like, yeah, we have seen this pyramid of pain, like, what about it, right? Now, so what we are saying is, let's flip that game right now. Like instead of looking at the pyramid of bottom up, where you start building the hashes, you start building the next level of detections, increasing the complexity of the detections, flip the pyramid, and then kind of, reverse it in such a way that you can actually manage them. The approach that we have taken, like in our one of the past companies, as well as right now, that's really looking for majority of the organizations, is we look at all the raw events. Doesn't matter what type of events it is, whether it's network, like cloud related infrastructure, your endpoint related infrastructure, doesn't matter. Like it could be any events that we are capturing, or even the artifacts of this, the systems that are out there. We collect those, and then we build something called threat identifiers. So think of these your base level detections. This could be your hash level detections, or this could be your simple like Yara rules, depending on different types of detections. Each of you are building all of these right now. The challenge with the next step is you're sending these set of detections, the alerts coming out of these detections directly to the triage side of the house. That's where people are struggling because the volume of these are really high. And so the triage side of the house is trying to consolidate them, come up with story around it because they really don't have context. It's a point in time, like on the very isolated event. You now have to form the story around it and determine what actually has happened around it, what actually has happened, like within the is there any later movement? Like you're trying to determine a lot of artifacts to form a story that we can justify and then make a decision whether it's a benign or a malicious event or a false positive, right? You're trying to justify all of that. It's an ongoing process that happens in everyday SOC. What we really want to do here is, yes, you can generate these events, but add an additional layer on top of it, right? Don't just send directly the raw alerts from these tools or from your detection engines to a triage analyst. Like just put another layer on top of it. Some people have tried it with the source solutions. I don't know if any of you have been using the source solutions, but like tools like the XOR or the SOAR that are coming up, they try to kind of consolidate this event, like fetch the external threat intel, like do all the enrichment in terms of like the hosts or the artifacts, and then send it. Again, that's you're trying to put a band-aid at the very end of the game rather than actually trying to solve the core cause of the problem. So that's where we kind of introduced another terminology called doing a correlation. Right now, we've been talking about correlation, but industry has not really been using it really effectively. So that's where we kind of brought it, which is threat scenarios. Like you're trying to form a scenario out of it, right? You have raw events; those generated some of the raw alerts, we call it, or events of interest, traditional alerts, and then we try to correlate all of them in different shapes and forms, depending on the size of the organization or depending on how you approach your SOC. You could build based on a risk framework. You could build based on a threat build, depending on how complex your SOC is. Like, if you really have a threat intel team and if you're really worried about, like, managing the threat landscape and then kind of understanding and then reporting that metrics up, you could just really build your threat scenarios based on the threat build. If not, like, you can simply just say, okay, I don't have any of that luxury. I don't have, threat intel teams. I don't even know who the threat actors are. Let me just start with a simple correlation engine. Right, it's just based on risk, and then like I'll try to consolidate based on certain factors. That's where we generate the alerts that are really less in volume and have full story around it. But what we do in this whole process is we're enriching at every single step of the way. You're not just enriching at the very end of the tail, where that's where the source solutions are trying to work. Instead, every step of the way, where you're actually generating traditional alerts, you enrich each one of them. Because what that will give you is a better correlation story at the very end, where you can actually form the story in a much more confident way. And you also have another full story to kind of, when you're triaging it, when you're reviewing, even for the level 1, you need not even have a level 3 or level 4 kind of reviewer. with the level one itself, they actually have the full story to make the determination, because now you really don't need to pass it along. So that's the beauty that we have seen. And like this methodology worked for a lot of our customers, like a lot of the customers, like our customers right now, we have a lot of Fortune 100 customers right now, because pretty much all the large enterprises are using this framework. I mean, whether it's us or even whether they build it, a lot of them are trying in this approach and they're seeing results. If you're familiar with Splunk's RBA, like it's a rule-based, risk-based analytics. They started with this concept, like a lot of different people are trying it, but we kind of made it more simplified in such a way that it's you do the enrichment, you do everything at every step of the way, not just at the very tail end, which is going to cause you a pain. Do it at every step of the way so that you have metadata to make the right decisions at the right right point in time. Eliminate all the false positives because you already enriched all the details. You can make a right decision to eliminate any of the false positives. So by the time an alert is generated, it's usually a handful. Like what we have seen is a case where there are 10 million alerts that are being generated for a single SOC. It's a large organization, but 10 million alerts, like imagine that being triaged by, they have about like 13 people across like 2 different time zones, 13 people, 10 million alerts. I mean, there's no easy way that they're going to cover any of them, right? And there is no easy way to prioritize them as well. Like, how do you even prioritize any of it, like, and make a right decision of which ones I'm going to triage right now? So with this framework, what we have done is with the 10 million alerts, we actually got it down to 130, right? It's a big, shut down that we got with this framework where now it's just 130 alerts. So divided by, 13, like it's 10 alerts per day per analyst, which is much more consumable. And we give enough time back to them so that they can think about a lot more other things where, you can do a hunting or you can start building additional detections. The possibilities are wide open, right? You're not just training in triaging the alerts itself. Instead, you're actually focusing on making your life much better, right? The biggest, pain point that triage analysts, at least the triage side of the house, is that the alert volume. So we have solved that problem, which gives enough room and confidence for them to grow and then stick with the company, have a better life as well, right? So what we have done, and if you look at how the whole framework is, right? The very first level of detections, we call it threat identifiers, right? It's because it's an identification detection. It could be as granular as possible, right? You could have any granularity. It could be at the hash level, it could be at the DDT level. Doesn't matter. It's a granular detection. You're not doing any correlation. You're not doing any kind of sophisticated detections. It's like you can have actually ML-based detections as well, like Outlast, for example. They're really noisy, right? But they're meant to be noisy because you're detecting a point in time, event that it doesn't matter. Like it's just purely based on a very simple logic that you're applying and then trying to generate alerts. Now, what we have done is essentially if you start producing these into a single set of framework, which we call it events of interest. Like these are all the different events of interest where it's much easier for you to kind of do any kind of hunting or kind of reviewing these events, whatnot. There's so many things that you could do if you get this whole consolidated list of base level detections. And then you build that scenario, it's like you build in a sequence, or you build in correlation by grouping, by a host or by a user or by an IP or a domain. You can try to slice and dice the same data in a different sense that fits, how you're approaching. Like you can even do hunting based on your hypothesis. You can start with the hypothesis. You can try to prove if your hypothesis is true. If the hypothesis, that's what you do on the hunting side, but the challenge is you're always trying to go into the raw events to do the hunting, which is often time consuming because now you have to do the normalization, you have to do, you have to understand the data. So there's a lot of learning curve as well as the knowledge expertise that is required. We're trying to cut all of that down and say, how can a level 1 or a level 2 kind of approach all of this, different activities that the SOC does, whether it's, detection or, hunting or triage, doesn't matter which part of the SOC you belong to. How can we make it effective so that everybody can contribute? You don't need to always escalate to the senior people for, getting it done, right? So that's the level of details that this kind of framework, it's more of like a framework, right? This framework would kind of allow that so that on SOC management, like if you have SOC managers here, you're really worried about your people, right? Now you don't want to because you want them to grow, you want them to be happy, you want them to be sticking in the company. All of that can be possible if we kind of solve some of these core challenges, right? So what this will do, like, and I kind of mentioned about this hunting index, right? So what we have enabled, at least what we have seen our customers doing is, if we start building these the small events of interest, like or the alerts that are coming from the level 1 detectors. What we are, like I said, we already seen the case for true positives because now we are only generating a handful of them. The true positive rate have gone significantly higher, right? Because you're already building the stories, as you build these events of interest, you're enriching them data with like not just your the threat intel information, you can enrich it with your CMDB, your asset information, like whatever you have data access to, you can start enriching them. And then you can do you beat out the noise too, because if you have access to like, your ERP systems or like, your HR, like, depending on what data you have access to, you can start populating that metadata and then start eliminating noise at every step of the way. Because if you eliminate the benign events, like say, for example, your admin doing specific things. I mean, that's one of the most common things that happen when you're looking for any malicious command execution, right? If you know for a fact based on the data that you already have, you eliminate that, weed out that at the very beginning of the attack, right? So you're slowly building this whole framework where the true positive rate is grown up significantly because it's usually either true positive or mostly a benign. So we are kind of eliminating the false positive as much as possible. And then we're also reducing the manual effort that goes in every time in the entire SOC. Because you're not just like trying to day after day, like hour after hour, trying to triage the events. You're actually spending time in a more meaningful way, trying to understand the whole overall picture. You already have the overall picture. You're trying to make a decision at this part. So that's where people come in. Instead of actually trying to do stitching together, machines can stitch all of the data together. All you have to do is essentially give the human the power to make the decision of whether that's benign or not true positive, and then make the right decision to go ahead and do the additional remediation or the mitigation practices that have to be put in place. And then finally, like you can actually start target attempts. Like if your teams are really doing a threat actor analysis, like if you really want to up the game, right? You don't just start with an empty answer. You want to start looking at how the threat actors are targeted. I mean, which threat actors are targeting your organization, because your organization is depending on which industry you belong to and which geography you belong to. So you kind of profile threat actors in that fashion, kind of understand how threat actors are behaving, and then you can start trying to mimic their behavior and see, are you able to actually kind of detect them, like detect their patterns? Because now that you have this base index of everything, where you actually have individual point of events, not just the raw events, but you have individual signals, you can start correlating those patterns in any shape or form to kind of determine, is this like, is this aligning to a particular threat actor, or is this profile matching to a particular signature, right? You can start doing all sorts of different possibilities. Like, our customers, at least, like, the framework when we propose this and the value that they see is huge, because we have freed up so much of time where they're actually using this for hunting. Like, all the teams, the big advantage that they're seeing is hunting specifically, because they never had time to actually do the hunting. They have limited resources. It's very common from the SOC where they really have limited resources and they don't have budgets to kind of really go hire additional team just for doing the hunting, because they really cannot justify. Now that we have freed up their triage or the detective engineers to a certain extent, you can actually focus their part of time. It's not, you're not focusing entirely of time, but at least part of them on doing this hunting, which helps benefit the team itself much faster. So let's take a look at an example, right? You understood the concept, like I kind of gave the framework. Let's take a look at the example of how this all can be put into practice. Take a very simple example, like we'll pick the extraction group, like say the quantum, right? You kind of see this process. This is kind of given like mostly it's open-ended at this point. Like you kind of go through the different processes of all the way from execution to impact. Like you go through like there's a privilege escalation, there is the defense evasion, different tactics being used, additional access. Like there are different sets of things that kind of happen as part of this. If you look at their signature of how quantum kind of performs. I've kind of broken it down. I'm not going to go into each one of them, but you kind of understand it. They use different tactics and procedures to kind of, penetrate and then kind of, impact, do the, get access to your environment and do whatever they're trying to do, right? And that kind of signature kind of, applies to pretty much any ransomware that you can think of, or any kind of threat actor that you can think of. Like they are usually grouped by either, some of the tactics and the specific procedures that that particular threat actor has. So in this example, what I'll do is I'm breaking down into two different scenarios. One is the initial set of things where you're doing the initial access, followed by some kind of discovery, and then kind of creating a backdoor, like essentially you're creating a scheduled task to do certain set of activities. And the second scenario is more about additional discovery. Like once I've established a foothold, how can I expand into the environment itself, like a kind of a lateral movement. Right. So I'll break down into those two stories, and then we can talk about how we can actually find it. From the detection standpoint, like if you're looking from a detection engineering perspective, like how the traditional detection works, you start building these individual strategies. Like okay, you have to first find the initial access, which is in this case example, it's DLL32, right? You're trying to find how can you detect the DLL32. What I have here is essentially a sample code from Splunk. How we build the Splunk logic. I don't know if you're all familiar with Splunk. But in essentially, it's like a detection engine or a data lake, and then you can start building rules on top of it. So what we are building is more of a scalable, SPL core where you can plug and play different modules, but then the logic can be defined in such a way that it can apply to different customers, right? So in this example, all you're doing is like you're trying to find a process creation with run DLL32. That's one detection. Then the additional second detection is discovery. In this case, like it's the process creation with either you're looking for some kind of IP config or like test, whatnot, right? There are several set of commands that are being executed by Quantum. But what we really want to do is we want to break them down into individual pieces. Instead of grouping everything into one discovery detection, we broke them down into small components so that we can determine and then kind of reuse that detection across different signatures. It need not be in one single detection, because if you combine all of them into one, it becomes it's a higher level of granularity. So to do the correlation, it becomes a little complex if you want to apply similar technology and similar strategy for a different threat actor. So that's why doing as granular as possible really helps you unlock this potential for combining things in any shape or form. And then finally, you have scheduled tasks. Similarly, you're going to create a scheduled task where you're trying to understand there is a task got created and whatnot. So in this example, again, you're going against win event logs. You have you can see the search where it's going against the specific win event logs and then the event code and whatnot. Another thing is we kind of separated out 85, because 85, the reason for separating out 85 is sometimes it could be used by the admins itself, or sometimes it could be used by by the malicious attackers itself. So if you understand those processes, the specific processes that are used in conjunction with how the attackers use, if you segregate them out, then eliminating the noise would be much easier rather than bucketing it. That's why going as granular as possible, understanding how your team works as well as how attacker works kind of helps in this segment, because you're trying to segregate them in a nice, easy way to do additional things down the stream, right? And then NSLOOKUP, for example, NSLOOKUP again, it's a very widely used command. Not just the attackers use it, pretty much entire your teams use it. It's not just admins. A lot of people within the organization use it. Everybody from IT infrastructure, everybody uses it. So that's why any of these granular things that depending on how well they're used, which teams use it, breaking them into separate detections kind of help you make the fine tuning much better. Right. So that's one of the core essence of this framework is you grow as granular as possible. That will allow you to be more flexible, when doing the correlation, when trying to do the identification. Again, another detection would be the WMIC. Again, it's similar concept like NSLOOKUP. WMIC is widely used in various contexts and various frameworks. So you really have to segregate it apart. And then let's form the scenario, right? You have built all these detections. If you look at all of these detections, we have built maybe about 7 or 8 individual point detections, what we call threat identifiers. Now, what we are trying to build is more of a correlation, right? You can build a correlation simply just based on the tactic level, right? You can simply say initial access followed by some kind of execution, followed by some kind of command and control. It's very simple as we can get, or you can get as granular as possible, where you're saying, okay, this specific signature in this case It's, the stage one is more about the run DLLs as well as, whatnot, the different way executions of run DLL, followed by a stage two, where it's more about the discovery, which in this case, the IS discovery commands that we just talked about. And then finally, stage three is more about either a persistence or a defense evasion. So you could combine and, build this, kind of a sequence in either as granular as possible or as flexible as possible. That's up to you. It's based on your appetite, like from the triage side of the house, because going granular would be much more easy because you can build playbooks around it. You know exactly what to prescribe to the triage side of the house, and it's much easier for you to do the remediation side of the house. But if you be granular, if you make it more agnostic and more high level, it becomes a lot of complexity because now you have to really understand, look at the raw events, and then you look at the alert that got generated, and then have to make the decisions. So there's a lot of ifs and buts if you make it at a generic level. So we usually kind of recommend it going there as granular as possible, even at this layer too, because then it's much more prescriptive. So this is one simple example of how we work, like, with a span of 10 minutes between each stages, like, essentially within 20 minutes of time frame, you're seeing all these events that are happening together. If that gets detected, trigger an alert, right? It's as simple as you can get. And then the second scenario of continuing that story is essentially the AD find commands and the WMSCs and whatnot, trying to group them into how they can be executed. Like we kind of analyze the pattern of the quantum, and then this is how it can be structured. Within a 30-minute window, if you have like an AD find followed by some kind of WMSC, you detect an individual signature by itself. The reason why we're segregating this into two different scenarios is also one thing. The reason is, if you hit the first pattern, right, and if for any reason you're able to detect it up front, it's much easier for you to lock it up front instead of waiting for all of the entire scenario to be triggered. So again, it's more of like trying to play as understanding of, okay, let's do the initial, like, when the attacker gets hold of the infrastructure, let's do a detection at that point itself rather than waiting for them to go and expand laterally and then whatnot. So it gives a leverage for the team to detect a little early in the game rather than just waiting for, the end game, right? So that's precisely why we've kind of broken it apart into two different scenarios rather than just having one single scenario. You can technically build it into one single scenario as well. It's just that the time to detect would be a little longer because you have to wait till everything happens. So you just have to play that nice balance of what would be a right thing where I can really tell the story. I know that I can, say whether it's benign versus, true positive, but at the same time, I'm not waiting too long, right? And it's a nice balance that you really have to play from a detection engineering standpoint. That's how we kind of build it. So if you look at this whole, framework, how we built it for quantum, the core essence of all of this is like, you're breaking it down into the smaller components. It's very small components that you build at the very first level. The level one detections are really, really consumable, and they're often driven by your threat intel or your, your red team assessments. Like, depending on how your teams kind of build your detections, you take all of that, intelligence and then start building these granular detections, right? Which is very, very mostly at the procedure level. You're not actually building at the technique level, go all the way into the procedure level, because then you can really iterate in terms of how you can combine them at the correlation level, right? And then like finally, once you build all of this basic, at the procedure level, then you can start building the correlations in any shape or form. Like, you can combine and cross correlate different, the same detection, the same threat identifier detection could be used for n different scenarios, right? So you can start building those. You can start building detections for your open-ended servers. So you can start building the same detection. Use the underlying detections for malicious attacker itself. So you can start. It gives you much more flexibility in terms of how you can slice and dice the data. So the big advantage is if you start doing this way, like I said, it's much more extensible and modular. You can combine and shape and things in a shape or form. And then you can also be very targeted of how you're approaching the detection. It's not like open-ended detections. It's not like ML-based detections where it's wide open. It may or may not be this actor. It's more targeted. Like you define the scenario, and then if it triggers, it actually makes sense for you. Now, I kind of gave you one example, right? Again, going after, like, depending on your size of the organization, not everybody may have the full-blown threat without teams, like full-blown teams that start building these kind of detections. If you are short on resources, what we have prescribed for majority of the customers is kind of, a pattern-based approach. Like, if you look at most of the ransomware, they have a similar pattern, even though the actual procedures may be different, but they kind of follow the similar pattern of, you start with initial access. Some kind of like, in this example, this is one particular ransomware example, where there is like, Windows macro execution, followed by some kind of installation, like, where there's a process that gets run, and then like, some malicious code gets installed. And then finally you see a command and control where they're, calling phone and then calling home and then getting, the payload done. And then finally, like you start seeing the discovery happening within the, environment, right? It's a similar pattern for most of the ransomware, like initial access, followed by installation, command and control, and discovery. If you kind of codify that in this framework where you're building correlations not based on individual detections, but more at the tactic level and say, I'm not worried about which particular technique or the procedure that they use. Just tell me if any of this pattern follows, like in initial access, installation, command and control, and kind of discovery. Then you can pretty much detect any kind of ransomware out there. That way, you're not worried about the attackers changing their patterns because, of course, the threat actors evolve. So they really want to evade your detection strategies. So this is one way of, giving that granularity where you still will have your base detections, but you want to have the generalized detection where it can, kind of detect at a high level. But in this process, there is another bigger, elephant in the room where building these detections is not that easy. Like, if you look at even the simple detection of the 4 different stages, you have 4 different individual rules that you're building for each of the data. And then you have a correlation rule that you're building at the top of the funnel, which is like, 5 different rules that you build. And then you have to do all the enrichment, documentation, whatnot. There's, a lot of things that goes around it. I don't know, like, from the audience, like, how long would you usually take to build these 5 detections per se? Like, or even one detection? What's your estimated time frame of building a detection, moving all the way to the production? Any guesses? Anybody? No? All right. So what we have seen, at least like, from our customer base that we have been talking to, like, between 400 or 500 customers, is they take anywhere between 3 to 5 days for single detection, right? Because you have to first do the research, you have to, get the right intel to make sure you're doing the right detection. And then you have to start building the detection, you have to test it, you have to do the whitelisting, whatnot, like, do all sorts of analysis before you move to product. So this entire end-to-end process could be ranging from, a couple of hours to a couple of days, depending on how well your team is, capable of implementing it. Because there's a lot of dependencies on other teams and whatnot, right? So that's what it really takes. Like, that's what we call it detection engineering, because detection engineering, I don't know how many people are familiar with the whole detection engineering lifecycle, but when you look at the whole, how the detection really happens, there is an engineering lifecycle. If you're familiar with the SDLC, the software development lifecycle, it's a similar strategy that happens within the detection as well. Because you have to start all the way from threat research to do kind of a document, like, to do red team or blue team assessments, kind of analyze, get the payload, then build a detection, test it, deploy it, and then once you deploy it, it doesn't end there. You have to maintain it every day. Because you have to look at the detection, make sure it's running, it's getting the right data, everything is happening every single day. And then finally, you have to report up to the chain, up to the management to make sure how well are you doing with all of this, right? It's a whole life cycle. So let me just kind of go through, like, this is kind of what I kind of explained right now, right? You have all of these different stages. Again, these could change depending on the size of the organization or like, how well your SOC is. But and most likely, like, this is kind of the rough schema that we have identified for most of the customers, right? So here is what we have done. Like, with the example scenario that we have seen, the ransomware example, it usually takes about 15 days across the board. This is 70 to 80% of the customers or the organizations take 15 days to build that one ransomware detection across, like, doing that 4 detections, 1 correlation, building threat intel into the picture, like, doing, cutting down the false positives. 15 days is too long, right? How do you cut it down? Because that's where most of the complexity comes. It doesn't end. It's not just one ransomware that you're going after. Like, you're actually going after, a lot of different things. And the threat actors are evolving. So, it's a constant battle that this is where the whole loop comes into the picture. So we want to eliminate all of this. Like, we can actually, like, with the framework that we've introduced, we've actually cut it down, and with our product that we've built in, so we kind of cut it down from 15 days into a matter of less than 1 hour. Right, so that's the power that we're giving it to the detection team. So where you can actually start being more effective, right? Again, it depends on your organization of how your team is approaching, but the way you look at it is, this is your overall process. You may have disjoint tools across this, because what we have seen additionally is you have different people doing all of this and different tool sets that we use at each of the stages. So consolidating them into one single location, at least as much as possible, is a big move, because you are trying to have all of this in a one single tool, or one single, like at least between the single team that can actually start executing and make much better decisions. So optimize this life cycle, the end-to-end life cycle of detection engineering would enable your teams to be much more effective, right? So again, the last very part of this is metrics. I mean, all of you may be hands-on, like, you start building these things, you start building detections day in and day out. But how do you actually, give metrics to the management? So CISO, for example, right? They're always worried about, they think about it a very different angle than what you all think. The reason is the CISOs kind of care about, okay, am I covered for this particular threat actor, right? If it gets breached, like, where are we with it? Like, how well are we equipped to kind of, remediate? How well our SOC team is doing? How can we be more productive? How can I do cost cutting? So the level of thinking is a lot different when it comes to the CISO. So how do we bridge that gap between the actual SOC analysts versus like the management side of the house? That's where we kind of build like a whole effectiveness program, right? Think of this like, we've introduced a similar concept called maturity score. Similar to our credit card scoring mechanism, like, we all do, like we all have a credit score. It's a similar concept that we are applying to the SOC, where SOC can measure themselves day in and day out, rather than just doing a once in a year kind of analysis. It's a continuous assessment of where are we across the different gamuts of the SOC, right? The initial thing starts with the collection, because everything is all about data. Because your entire detection program, your entire SOC engine kind of relies on how good your data is. That's kind of your bread and butter. The bad data in, bad data out. So that means your entire downstream applications are going to get crumbled if you really don't have your data thing sorted out. So that's why, like, you really need to understand what data are you gathering, like, what's the quality of the data that you're gathering. Actually, it's not just about the data, gathering the data, it's how well you're gathering the data. Like, are you gathering for all the environment, or are you gathering for a subset of data? Right. So you have to look at all of them and how available it is. Like, is it coming in frequently? Like, are you losing some data? So there's a lot of things that comes in at the collection level, and then you have to strategically kind of escalate that in your different communication metrics for the board, which is like how what specific technologies that you're embedding in your infrastructure. Like, is there industry specific risk from like being in a specific industry that you're being targeted on? What specific risks that you have for your specific organization? So there's different sets of risks frameworks that you have to bring in at this point in time, so that can be blended into your detections. Once your detections are strong enough, you can pretty much use your MITRE, for example, if you're already using it. You want to cover as much as possible that is pertaining to your environment. It's not that you want to cover the entire MITRE, because a lot of MITRE things may not apply to you, but you have to understand what parts of MITRE specifically applies to you based on infrastructure that you have and the threat actors that are targeting you, and then make sure you're covered for that gamut of the MITRE. And once you've done that, that's your detection side of the house. Now you do the start doing the correlation, right? And then finally, how is your response side of the house? How well are they being able to triage it? Like, how fast are they triaging it? What's your MTTR? Like, there's different metrics that you can start, analyzing. And then, what can you do? What's the workflow is like, how much true positive are they actually looking at? Like, because it's a feedback loop that you start building between your detection team, your triage team, your hunt team, and your data team. If that's a completely different team, that's a big challenge for most of the SOCs, because that usually sits outside of the SOC. So you have to start managing all of these 3 or 4 different teams, make sure there is a feedback loop between each one of them. Again, you have different tools for each of these teams. So consolidating them into one single infrastructure, trying to have a balance and very well communication between these teams is usually the key to kind of eliminate a lot of the challenges. So that's what we have seen. And then what we do is when we build all of this, we build scores for each one of these pillars, like the collection pillar, the detection, the response, and then combine them into the overall SOC. Like, this is what your SOC is, this is how well your SOC is performing. And this gives a metric for a CISO to kind of understand where we are, which parts of the SOC is kind of struggling, where do we need to invest for the next year or next 2 years, right? So it gives a really quantitative way as well as a qualitative way to kind of discuss and then debate and whatnot. So that's kind of, the key summary of the overall framework that, we've built, and it's kind of working with majority of the organizations. So key takeaways, don't worry about the low detections, low quality detections, let them come in, but, build as many of them as possible. But don't look at them as the first level of analysis, right? Build a correlation engine on top of it. However you choose to do it, you can still use the existing tools that you already have, or get a new tool that can do the correlation for you. Build a correlation on top of it, and then do all the enrichment up front, for the low level detections, so that you can be really better at doing the correlation. And then again, build that hunting index, however you structure it, whether it's being a data lake or a sim of your choice. Bring that, bring all of those events into one single index, because then you can power not just the detection team, but the hunt team and the triage team to be really, really effective, because they can start building more and more ideas. And then finally, build up your measuring criteria. How do you measure yourself, and then how do you, percolate that measurement to the next level, to the SOC manager or to the CISO, right? How do you, bridge that gap? Because, you're at the very root of everything. And then if you can't communicate that to the next thing externally, it gives a lot of challenges. That's where a lot of complexities comes in. So build up that framework of what key metrics that you really want to build up. How do you measure? How do you, give a CISO a visibility, the challenges that you're running into, but at the same time, the effectiveness that you're bringing to the team, right? So MITRE could be one simple example. We have increased the MITRE coverage by X%, but we really are challenging with, extending the coverage to these traditional X%, primarily because we are dependent on data, for example, right? You could kind of build that framework up to kind of present that metrics to the board level and whatnot. So one another thing that we could do, if you guys are interested, we generate these threat reports, again, based on every day, whether it's based on threat actors or the evolving, threats. We kind of give these threat reports. We kind of give you this framework of what are the base level detections and what is the correlation. So if you're interested, you can start following us. At least you can understand how our thought process works when we, think about any of the threat actors, and then you can start implementing in your tools that you are currently leveraging. With that said, quick shout outs for the data that we've got here, the FR and putting down pain, whatnot. If it's not too late in the day, I want to quickly pose a quick question. I don't know how many of you are, paying attention, but I talked about low level detections and high level detections. Can any of you say what was the low level detection versus the high level detection? At least the terminology. Never mind. It's Saturday. I'm not gonna force you here. Threat identifiers and threat signals. All right, that's it. Thank you so much.